Continuing in our study of anatomy, we're going to be looking at the levels of human body organization, the different levels of organization. So, life processes of the human body are maintained at several layers of structural organization. So, these levels they include the first one is the chemical or molecular levels. These are atoms, and atoms are the smallest stable part of matter, and they combine together to form molecules with complex shapes. So this is the first level. The second level are cells. These molecules they interact to form organelles, and organelles are the structural and functional components of cells. But when cells come together, they form tissue. So a tissue is a group of cells working together to perform one or more specific function. So when cells come together, they form tissue, and when tissue come together, they form organs. So organs consist of two or more tissue working in combination to perform several functions, and that's the organ level. Then we have the organ system level, which is when organs they interact with each other to perform a function, that is they form a system. And when all these systems work together to maintain life and health, that brings us to what we are, the human being. That's the organism level. So next we'll talk about organs and systems in the body. Organs in the body are the organ systems are interdependent, interconnected, and packaged together in a relative small space. The cells, tissue, organ, and organ system of the body live together in a shared environment like the inhabitant of a city. For example, in a city, there's a water company that provides water that the people of the city they drink and use to do other things. So if the water is infected or contaminated from that source, and the water people drink it and everything, people will become sick. That is the same way it is in our body. If the body fluid composition something changes there, the cells in our body will die, or they will be injured or destroyed. So if, for example, the temperature of the body fluid changes, it will affect the cells in our body, and it will affect our normal day-to-day activity. So there are mechanisms, there are things that the body does to prevent something like that from happening, and that is what we call homeostasis. So the various physiological mechanisms that acts to prevent potentially damaging changes in the composition of body fluid and the environment inside ourselves, these mechanisms are called homeostasis. So what our body does to prevent those changes that can cause harm to our cell or destroy ourselves, we call those mechanisms homeostasis. So what is homeostasis? Homeostasis is the most important part of anatomy. It's a saying that says homeostasis is life, because without homeostasis there's no life. So the definition of homeostasis, if we break it down, homeo meaning unchanging and stasis meaning standing, refers to the existence of a stable internal environment. To survive, every organism must maintain homeostasis. So homeostasis is the maintenance of a stable internal environment in the body, maintaining the inside of the body at a constant rate. That is what homeostasis is. Everything in the body, for example, let's take for example a salt, maybe sodium in the body, it has a range of 11 to 13 mole per, just for an example. If it goes above that range, it is not good for the body. If it goes below, it's not good for the body. So keeping the sodium within 11 and 13 for that example is homeostasis, and the body uses different mechanisms to accomplish that. Those mechanisms include the negative feedback. Negative feedback promotes stability by counteracting changes of various properties from the target values known as set points. Examples are thermoregulation. Negative feedback, when a range changes. For example, like that example I gave, sodium, once it goes above the range that is meant to be, negative feedback brings it back to that range. There are different ways the body does that, but it's bringing it back to the range that it was, the normal range that it left away. If it go lower, bringing it back up. So for this example of thermoregulation, the body has a constant rate, temperature range, and that is 37 degrees Celsius. So at all times, the temperature of our internal environment of inside our body must be 37 degrees Celsius. But different things will affect it, and sometimes our body inside will get hot or get cold. Maybe the weather outside, what we are wearing, different things. So how does the body maintain that temperature at 37 degrees Celsius? The first one is sweating. So sweating is used to lower the temperature. So on a day we are feeling very hot, maybe the weather is hot, you notice you are sweating more. That's the body reducing the temperature. That means the temperature in the body is going above 37 degrees Celsius. So the body is bringing back to 37 degrees Celsius. So you sweat, and sweating will cool down the body temperature. On days when you are shivering, it's because of cold. So that shivering is raising the temperature. So those are negative feedback mechanisms. When there's cold, you'll be shivering to raise the temperature back to 37 degrees Celsius. And when it's hot, you'll be sweating to lower the temperature back to 37 degrees Celsius. So those are examples of negative feedback. Next one we have is positive feedback. Positive feedback promotes a change in one direction by amplifying the initial stimulus. So, for example, if like that range, it does not happen for temperature, but I will use temperature so that you get it, so that you follow the same thing. If, for example, positive feedback controls the temperature range, once the temperature leaves 37 degrees Celsius, instead of it coming back, the body will continue to amplify that change. So once it leaves 37 degrees Celsius, it will continue to increase it to 38, 39, 40, 41, 42. So that's positive feedback. It will amplify any change that occurs to that stimuli. So of course that is not good for temperature, because the body needs to be at 37 degrees Celsius, but there are other things that this is useful for. So this is rare compared to negative feedback. Negative feedback is the most common, because most things in our body has a range that they must maintain. But positive feedback is useful for things like childbirth and blood clotting. For example, in childbirth, there's a release of oxytocin, which is a hormone that the posterior pituitary gland releases during childbirth, and it allows the muscle, and it stimulates the muscle that contracts during childbirth. So if the range, so when a woman is in labor wanting to give birth, the brain is going to release that oxytocin hormone that will make the muscles to contract to push the baby out more. So once it leaves that range, it will continue to increase. So the contraction of the muscles will continue to be more and more and more until the baby finally gets out. So it's promoting a change in one direction, increasing the production of oxytocin. So it's getting more and more. Even though there's plenty, it does not reduce the level, it continues to increase it. So that's positive feedback. Also for blood clotting, platelets. When you injure yourself, the body will continue to produce platelets until that area that you injure yourself is covered up. So the body will continue to produce platelets. So those are examples of positive feedback. Feed forward, or it anticipates changes and prepare for it. So feed forward is a newer mechanism that was recently discovered. It anticipates changes. An example, the heart rate. For example, you want to go on a run. Like we know, when you want to run, the optimal heart rate for running is about 100 beats per minute. Why when you are just sitting there and resting, it's about 60 beats per minute. So you are preparing to go for a run. You have not started, you are still at rest, but you are preparing, you are thinking, I will go for a run soon. Your heart will start beating faster, closer to that 100 beats per minute. Your body is preparing, your heart is already beating 100, even though you are still at rest, but in preparation for that one, so that when you start the run, you'll be at an optimal heart rate. So the body is anticipating change and preparing for it by raising your heart rate. So that is the mechanism of homeostasis, and homeostasis is very important because homeostasis is life. So thank you for watching. Peace.